Azar, Carl, John, and Sergey are the 4 players left in a singles tennis tournament. They are randomly assigned opponents in the semifinal matches, and the winners of those matches play each other in the final match to determine the winner of the tournament. When Azar plays Carl, Azar will win the match with probability 2/3. When either Azar or Carl plays either John or Sergey, Azar or Carl will win the match with probability 3/4. Assume that outcomes of different matches are independent. The probability that Carl will win the tournament is P over Q, where P and Q are relatively prime positive integers. Find P plus Q. Interesting. So I guess what we want to do, we want the probability that Carl wins the tournament. I just need to figure out, first of all of the, basically of all possible starting arrangements of the bracket, we are given sufficient information to figure out the probability that Carl wins the tournament. And then, of course, depending on the original arrangement of the bracket. So if Carl plays Azar first in the semifinals, I think that's what I'll do. Okay, I'll break it down. So John and Sergey are essentially equivalent people. They are like, we can treat them as identical based on the information we're given. So I'll break it down into 2 cases. One where Carl plays Azar in the semifinals, and then we can compute the probability he moves on to the finals, and then also the probability that he wins in the finals. And then we'll have the probability that Carl does not play Azar in the semifinals, and I should be able to figure out again the probability that he gets to the finals and the probability that he wins. That one will be more complicated because so let's start with that one. Let's start with the more complicated one. So I have C, I have S or J. So I'll just call that X for John or Sergey. And on the other side, we have Azar and another X. So the reason this is more complicated, if Carl loses this, I don't care. I only care about when he wins. So we have the probability that he gets through, which is given to us. But the thing is, there are 2 possible outcomes here that can affect the probability in the finals. Okay. So I know I said we're going to do this one first, but we're not. We're going to do the easier one first. So I have Carl and Azar versus X and X. So if that's the original thing, so the probability of Carl winning is going to be the probability that he wins the first game times the probability that he wins the finals game. And that is, so Azar wins this with probability 2/3, so this is 1/3 times when Carl plays X, Carl wins with probability 3/4. So that's 1/4. If this is the initial arrangement, Carl wins with probability 1/4. Okay, now let's look at case 2. So the probability of C is equal to, so the probability he wins the first match is 3/4. Then the probability he wins the second match depends on who wins that match. So if Carl's in the finals, it's going to be, the probability he wins against Azar is a third. And the probability he wins against X is 3/4. So what is the probability that Azar wins this match? It's 3/4. And the probability that X wins this match is 1/4. Okay. So 3/4, 1/4 plus 3/16. Let's write that as 4/16. I've got 3/4 times 7/16, so 21/64. Okay, so if the starting arrangement looks like that, 1/4. If the starting arrangement looks like that, 21/64. Now, what is the probability? And these are the only two starting arrangements, because the X is a placeholder for anybody other than Carl and Azar. Either Carl faces Azar in round 1, or Carl does not face Azar in round 1. And I guess the probabilities of that is it's 1 in 3, right? So I should have 1/4 times a third. I mean, I'm overloading notation here, unfortunately, using the same symbol for the same thing. But anyway, 21/64 times 2/3. So I've got 1/12 plus 42/192. Okay. What's 192 divided by 12? $16. So I get 58/192. Divide that by 2. That's 29 divided by 96. 29 is prime, right? Okay, so I get that P plus Q is equal to 29 plus 96, 125. I just want to think a little bit more about my logic of the probabilities earlier here. So there's two cases. Either Carl plays Azar first or he doesn't. In case 1, he wins the tournament if he wins the first game and the second game. The probability of winning the first game is, okay, hold on. When Azar plays Carl, Azar will win with probability 2/3. So the probability Carl wins is 1/3. Once he gets through, he plays X and has a probability of 3/4 of winning that. So 1/4 by independence, right? We multiply the probabilities. In case 2, Carl wins the first game with probability 3/4. In the second game, Like there are basically 3 games we have to work out probabilities for. It's Carl wins the first and Azar wins the second and Carl wins the third. Or Carl wins the first, Azar loses the second, and Carl wins the third. So, I mean, if we distribute these and add them, it's because they're disjoint events. They're disjoint because we're saying, it's either one person wins this or the other person wins this. And if you condition on the 3 games, but you change the winner of one of them, those can't possibly happen at the same time. Okay, so the probability Carl wins the first is 3/4. The probability Azar wins the first is 3/4, and then Carl wins the last game 1/3. Yeah, I think this is right. So I'm not going to check my arithmetic. I'm going to assume my arithmetic was correct here. I think I'm more concerned with whether the whole process works or not. So I get an answer of 125. The probability that Carl wins the whole tournament is 29 out of 96. Yeah, I guess the last thing that I have to think about in terms of the logic is to make sure that it is in fact a probability of 1/3. Like case 1 happens with probability 1/3, and case 2 happens with probability 2/3. And I mean, there's 2 cases: either Carl faces him or he doesn't. And there are 3 people that Carl can face in round 1. So there's 1/3 chance that we get this match for case 1. Yep, I'm pretty happy with this. I'll check my answer though, and I'll let you know if I have a mistake somewhere. Thanks for watching.